So I think all of you should know your the nice lab for presentation, right? So
yes.
First, I think I would like you to maybe use your lab computer, right? If you want to do presentation, you can just join the do meeting, and then when the time's up, then you try to share your screen to the presentation. Then you don't need to put your your USB computer. That's very easy.
Okay.
Okay.
Yes.
Can we just use this computer?
You can do that.
Okay.
You can do that. Yeah. Yeah. You can do that. Yeah. Okay. Probably we can start now for the first group.
Okay. Good evening, everybody. We are here to present our project on real-time monitoring of neonatal incubators. It's actually an application of MEMS sensor for low-budget facilities in developing countries. My name is Oyetunde Kehinde. Our project starts from understanding what incubator systems are. An incubator is a system that is used to provide the stable and controlled environment for premature and ill baby for them to grow stronger. So it is designed to actually keep the baby warm and free from all external effects such as harm and disease. Around the world, we have the announced statistics of children that have been born before the required term to be 50 million. It's a huge number. And in most situations, what happens to these babies? Most of them do die. But then the death is usually common in remote locations in developing countries. From our research, we observed that 75% of the deaths are actually due to lack of proper incubation system and the monitoring system. Hence, the inspiration for our project is to detect early abnormalities in the critical parameters in incubators. Looking at it, for the biological parameters involved in incubators, usually when you want to put babies in incubators, you want to put them in a situation that is much similar to the womb. Okay, so in developing countries, which is our motivation, usually the state-of-the-art incubators are usually expensive, and they need high-trained professionals to be available, which is costly. So mostly countries have to make do with simplified devices which are cheap. In a much simple way, we need to control the temperature and humidity. For infant babies, they are so delicate that they find it very difficult to maintain a constant body temperature. And they have this extreme heat loss, which they lose as much as 1 degree Celsius per minute. But then their body temperature has to be over 35 degrees Celsius. And anytime it's less than 35 degrees Celsius, they can have life-threatening conditions which can lead to their death. And also, within a very short period of time, they can have highly unstable conditions. When it comes to the humidity, it is known that premature babies have a very thin skin, and as a result, they find it very difficult to keep the humidity of their skin. And what happens is when there is continuing water evaporation from their skin, it could lead to them having life-threatening conditions which can lead to their death or even infections. From research and academic papers, the required temperature range for infants, premature infants, is 36 to 37 degrees Celsius, and they need to maintain an humidity between 70 and 95%. Hence, we propose a solution that is cost-effective, is real-time based, and is easily deployed to low-income based countries. Now I'm going to go over the technical details of our solution. We use the Node MCU, which runs on ESP8266. We also use the LM35 temperature sensor to capture the temperature. Also, we use the DHT11, which is capable of taking temperature and humidity but in this case, we use it to capture the humidity. Also, we use the 4.7K resistor and a liquid crystal display for visualization. Also, part of our components, we use a serial I2C LCD module to print data onto our LCD. And our solution aims at being standalone, whereby you don't need to actually provide power, because we envisage that low-income countries might not really have a very good stable electricity. So hence, our product has a 9-volt battery, which is changeable and lasts long. Also, there is a switch, and there is a 7805 voltage regulator, which converts any voltage, direct current coming from it, to 5 volts, which is required by our system. Then also there is a variable for the implementation. After implementing the whole thing, we have all this. But then this is never a prototype. We had to do some other things, which we're going to show much later. This is a circuit diagram which shows the detailed electrical and electronic connections of our system. For the prototype, we had to make a case which we designed a 3D of it, and we printed it out. So our case is basically a two objects, such that the shell is made from PLA and the cover is TPU. For our project, this is the block diagram. The microcontroller is powered with a 9-volt battery. The 9-volt battery gets to be cut down by the 1705, and then it gives the 5 volts needed by the microcontroller. Also, connected to the microcontroller are the MEMS sensor, in this case the LM35 and the DHT11, which gets the reading. The reading from the two sensors are shown on the LCD. Also, because we want to make our solutions, our results available anywhere in the world, we use the Wi-Fi module to make the result available online. In this case, the cloud. So we use the TeamSpeak to capture the data sent by our microcontroller. And also we designed an Android application to display the results. Our application is designed in HTML5, which makes it easier to be deployed on any platform, not only Android application. We can also deploy it on iPhone and Windows Phone. Basically, TeamSpeak is a cloud storage, is a cloud server for IoT data storage, analysis, and visualization, which we leverage on to show very beautiful visualization of our results. For the MCU, we had to do the settings using the ESP settings and the AP settings, which we are going to show you how we went about it. For the Android application, which the APK is available, this is what it looks like. The results for the last 10 readings, which is displayed in real time, is plotted variations of the temperature and humidity at every time. Also, talking about the Android application, it's made using HTML5, CSS, JavaScript, Bootstrap, and we exported it to APK. And the graphs are being plotted using an iChat, which is a JavaScript plugin available in TeamSpeak. This is the final product. So it's made such that it's simple and it's standalone. You don't need to plug it to anything, just put it on and connect it. And it sends the reading to the cloud, and it's visible on as many phones as possible. Now we are going to do a demonstration of the product. Okay. So basically, when you put on the device,
can you come here so that the outsider can see here? Not only for your prototype.
okay.
Here, so you see, then people also can see your prototype.
So basically, when you put on the device, you can see finally with the plugging it's not very nice, it looks for internet. Now it's connected to the internet as it is, and it's so using an Android application, I can easily go online and open my application to see the variation of the temperature and humidity of this particular place. So in essence, we're going to have this result. Okay. Now the humidity is 73%. Basically, this is what the indicator looks like. It's going to take data. It refreshes itself every 20 seconds. Okay, so the code and everything will be made available in the report. Thank you very much.
Any questions, comment on this prototype? Looks quite impressive because the guy was really bringing. Any questions, comment? Of course, I want to see if you have any comparison. Is any commercial or other people also do open source expenditure project?
At the moment, most we don't know about any open source devices, but usually the usual target is for the normal expensive system, and most of the things we've seen, they need you to plug it to the socket or something. That's the reason behind we making it standalone. So it works on its own. It connects to the internet on its own. You don't need to bother about anything. So basically, the node MCU works as a server and a client. It gets, it sends. And then for the last 10 readings, you can see it's not captured in real time. And it's not sent via Wi-Fi, it's not sent via Bluetooth. It's just on the internet, and the micro gets on the internet. Even if you are in another country, with the APK app or the iOS app, you get to see the results real time. So it helps to know the condition of the incubator in real time.
Another question for your prototype is, are you able not only to do the monitoring with all the sensors, also think about the control, provide some way to control the temperature?
Yes, at the moment, this is basically phase 1. So we're also working on the phase 2, but it's really time consuming. So basically what the phase 3 is all about is we using the Arduino to get the data from ThinkSpeak, and we control the temperature device and maybe the fan, the heater, to monitor to adjust the temperature in real time. So it's going to be more like a feedback system. But then it's going to take much time. So that's why we try to finish our phase 1 while we silently work on the phase 2. So the control is the phase 1 is the phase 2 part. But then this is the completed presentation of the phase 1.
Any question or comment for the prototype? This is I think we have So not only look at structure and programming, and also XP, and also the 3D printing. That's pretty impressive. Yeah. Any other question comment or from the other student group? So from my point of view, I'm pretty sure this do have some potential market. No doubt about it. Of course, this is only for time. If you really want to become real product into additional engineering, yes, that's the real research. Okay, so if no, I think let's do again. Oh, yes.
How was the presentation?
Can you share screen now? Or you can share?
Yes.
Share screen and the second group can give presentation. So what your first time? Can you put here so that the can see your first time? It's okay. Okay, I think you can start now. Yeah.
Okay. Today I'll do the application program. This is about a smart and stress detection method and analysis system.
We will talk about motivation for our project, and we introduce the principle of our device. I talk about hardware and what is the characteristic of our device. Then we show the whole effectivity. We will also show and talk about the sensitivity characteristic tool. And we will introduce the threshold gas concentration that we get for our device. We will then show accidentally develop that our gas concentration to its smartphone, and last but not least, we will demo product. So nowadays, in one way, we are surrounded by the gas. In particular, for use of HKUST, but you use for only desktop and also, for example, in terms of industrial and consumer applications, we have up to hydrogen parts and hydrogen and power. Essentially, get energy because
origin of gas or in my substance, or if it's any region that it could explode. So our device addresses the specific concern by measuring the gas concentration and temperature when the gas concentration is stable. So here you can see the principle of our device. So for several gases, we have different gas sensors, and the gas concentration. So the gas sensors work by converting voltage signals of the gas concentration measurement to Arduino, and we have set threshold values. And if a gas concentration would exceed one of these threshold values, then the system would notify the people, for example, by LED, by respective LED. So if one gas, for example, stage 4 would exceed our threshold value, then the LED would shut. Or if any of these cases exceed their respective threshold values, then also the other would start an alarm and notify people around our device. And also, besides, our Arduino board is connected to a multi-beam module so that the measured gas concentrations are sent to a smartphone, and the smartphone can read this some gas concentrations by a mobile application program that is written about food. And so here I talk about the gas sensors that we use. Has CR, I can note it as XQ5, XQ7, XQ30, and 4514. And so the XQ5 uses the thin oxide as the sensor layer, and then the fish practice, natural liquid test, and measurements in the concentration from 100 to 2,000 parts per million. And testing conditions are from -10 to 50 degrees Celsius for a relative community of less than 95%. And NP7 also uses oxide as a sensor, for which it senses carbon monoxide in the concentration range between 10 and 500 parts per million, and that's the temperature range between -20 and 50. SGP30 is a metal oxide sensor that can sense carbon dioxide, and a gas that is called total molecular organic compound in the concentration range from 0 to 60,000 parts per billion, and the gas in the temperature range from up to 55 degrees Celsius. And also we have a gas sensor, a MECH5950, that's also a metal oxide sensor that senses nitrogen dioxide and hydrogen from the concentration range between 0.05 to 10 parts per million. And we want to emphasize that our new device is low cost and that is Arduino based, and that real concentration gas measurements can be sent by Bluetooth to our smartphone to inform people in real time about gas concentration levels. And additionally, that that people would be notified by in background and report when any given gas concentrations are exceeded. And also, we believe that our device has high market potential because it has a wide variety of applications in vehicles. Then,
system uses the these other last send the data to the mobile phone using the Bluetooth. And yes, the system we connected about 6 LEDs to controlled by the sensors about the and output.
Relationship about the computation and the this.
Yeah, I mean, okay. And
Okay, please go ahead to quick presentation.
Okay, so we're group 3 and we came up with the Drinkinator 3000 automated drink dispenser. We came up with this idea because Hong Kong is full of busy citizens, leading to a high demand for small efficiency improvements in their busy lives. A highly efficient consumer lifestyle is needed, so contactless payment systems such as the Octopus have been largely adapted in transport costs, small purchases, and even haircuts. However, purchasing a drink at the bar remains an archaic process, requiring the customer to wave down a bartender, paying with cash or credit card, sometimes waiting several minutes before a beverage is obtained. Our project proposes to solve this dilemma through a fully automated drink dispenser system activated by the simple and familiar tap of an octopus. So we divided our project into 2 main sub-teams, mechanical and then the electrical and software team. We decided that the mechanical would cover mainly the component specification and purchases, structural design, fluidic design, packaging design of electrical components, and construction and assembly, whereas the electrical team would focus on selection module such as keypad input, LCD display, the RFID module, the volume detection module, solenoid control module, and physical wiring and packaging. Now I'll hand it off to my teammate to talk a little bit more about the mechanical aspect.
Okay, almost all the mechanical components are bought from the Taobao website. Yeah. We use the bottle standard to hold the normal plastic bottle, and that's all the mechanical components in our prototype. As for the this is the figure to show the tubing. We mounted the plastic bottle vertically in the bottle standard, and we connect the food grade silicon tube to connect the whole parts, and the solenoid valve is used to control the drink for each drink, and it also can. Oh no! When the drinks for the container. When the process is accomplished, it will send a feedback to the electrical part, and the solenoid valve will close. And this is for the whole process. And this is some details about the mechanical structure. As what I said in the last slide. Yeah. That's for the process. Now, next, my teammates will talk about the details in the electrical part.
So for the electrical components, these are the main items we used for the project. So first we have the keypad. So this is used to enter the drink number that you want. So you can choose numbers between 1 and 6 for different beverages. Then we have the LCD display, which shows your selection and some more feedback, which we'll show later in the video. We have the solenoid valves, which we control from the Arduino. And because these are 12-volt solenoid valves that we used, we also used a 5-volt relay so that the Arduino can actually control this circuit. And for the payment, we have RFID module, so we can use RFID to scan, just like an octopus can scan for your payment to confirm your drink. And then we have a buzzer to confirm your payment. And like my teammate just said before, we have a pressure sensor beneath the cup so that it can detect when enough volume has been reached, and the solenoid valve will then switch off through a feedback loop. And this is the overall sort of layout diagram. So yeah, you can see the components I just mentioned. Yep. And here is the schematic diagram showing all the functionality of the electrical components. And this is how it looks in real life. Yeah, real life business theory. So now my teammate will talk in more detail about each of these different modules.
So we start with the RFID module. Yeah, we use this module to enable payment for each of these selected drinks. So we use a simple RFID reader that has a serial communication interface. As many of you have probably used this, you probably know how it works better than I do. So I'll skip this part. So the RFID called inside this module detects the octopus and then processes the payment, and it enables the software to go to the next step, which is the pouring. However, when you're pouring the drink, the system has to know when to stop. So to do this, what we've installed in the system is a pressure sensor that detects when the cup has been completely filled with the specified volume of liquid. So there's a feedback loop, and yeah, when the volume reaches to the top, it stops. So we connected this membrane pressure sensor in a voltage divider configuration, as seen at the top right of the screen. And as you can see, we also include a 20 kilo ohm resistor. We did this because we wanted to linearize as much as possible the behavior of this feedback loop. And then the other problem we had is that the valves are actuated by a 12-volt signal, whereas Arduino can only output a 5-volt signal. And the reason behind this mismatch in voltages is because we need a high flow rate, and this can only be achieved with a solenoid valve that's actuated at a high voltage. So the solution we came up with was to install 6 different relay switches that are controlled with a 5-volt Arduino signal. So relay switches, as you probably all know, pretty simple electromechanical machines. So the way they work is they have a coil inside, and when you pass a current, the signal current, through them, it attracts the switch, and it switches from normally closed to normally open. And like that, you can actuate in our case, the solenoid valves we have downstream. So that would be all. And I'll
So here are just a few final pictures of our design at the end. You can see our teammate swiping his octopus card and confirming the payment. Okay, so now we have a couple of videos. I'll try to play here.
Good. Can I cheat?
The sound doesn't work for some reason.
But it's okay. Use your laptop computer has a microphone, right?
Yeah, maybe that works.
Oh.
There's a way.
Okay.
Up the flow rate, up, and you take a drink.
How good is it?
You can see what the actual user is saying.
I see.
The same. So TikTok, if you don't want TikTok, you can choose another one. Maybe you want a side. So you select your drink, you confirm, okay, payment okay, and it starts pouring. And then when it fills up, the sensor detects it and it cuts off the flow. We can.
Maybe you change your mind. You want blue girls? No, actually, no. I want a same girl.
I see.
Hash to confirm. Confirm. Please scan octopus. Okay. And then pouring. And
if you press, it will stop.
So you return with the glass, and then you have some pressure.
Wow.
And then drink complete.
Very impressive.
And then it just restarts.
I see. Anyone try? This is a real interesting type. How many sensors, but also this is RFID, right? Do RFID and also a touchpad and all things. Okay. How about the control of this kind of thing that you
You also bought it from Taobao.
Yeah, yeah. This one. This one, right?
How do you control? You mean,
So you connect to the voltage divider, so you can measure the voltage.
okay.
And when you apply, so the way this resistance,
So if you like it.
Yeah,
yeah, we can take it off.
Oh,
So yeah, we have to calibrate, so we choose the resistance that, is,
Okay.
that will be correct for the right
I see.
volume. So you
I
change
see.
more resistance
Yeah.
for less volume.
It's like it's pressure sensitive resistor, right?
Yeah, yeah.
Yeah, I see.
Yeah, that's
Yeah.
simple, yeah.
Yeah, I see.
But just calibrate for the correct volume.
Okay. Huh? It's very, very impressive. What's high? Any question? Anyone want to or on the street?
Yeah, so the only downside is it requires
I don't know. How about the next group? Huh? Not here? Disappear. Oh, let me see. Let me check. How about what happened to the group? It disappear? Mm. So next group should be a wearable smart musical instrument digital interface controller. Not here? If not, then probably go to the next one. A number 6 group, a touchless speaker control device. Number 6 on it. Of course, if you want, you can use your computer or use that computer. Both are okay. Yeah. Try to share your screen.
Good evening. We are group 6. Today we're going to introduce our device. It's a touchless control speaker. And I'm Donald and my group members are familiar. First is background. Touchless control has emerging as a popular technology in recent years. Touchless control and also gesture control removes the burden of physical contact between you and devices and make the interaction quite pleasurable. Here are some quite good examples about the devices and systems that use that kind of control mode. The first is the MECH5950 released by Huawei earlier this year. We can see from this GIF image that the slide changing and the screenshot can be achieved just by switching your hands or making this. And this gesture control is realized by the in-front camera, 3D depth camera, and the gesture sensor inducted together, and very sophisticated algorithm. And the second one is an interactive game system. The system can detect the player's movement and reflect immediately on the screen. So it gives you an immersive experience like you are actually in the game. And the third one is touchless watch brought up by Google. We can see that this watch does not have a physical button, but the watch can detect the distance to your hands distance to the watch and your gesture to adjust the time. Above mentioned technologies, they are very fancy and they use sophisticated chips and algorithms to realize all these complex interactions. But today, we would like to provide a solution to a scenario that we might all come across in our daily study and life. The first is like, I believe most of us do experiments which usually take hours in the laboratory. For me, I would like to listen to some soft music while I'm performing experiment. But I do chemical experiments, so I'm required to wear rubber gloves where I'm doing the experiments because to protect my hand from all the corrosive chemicals. But here comes the problem. Every time when I want to adjust the volume of the speaker or I want to switch a song, I would have to take off my gloves because I don't want to leave any trace of chemicals on my speaker, which is quite troublesome. And the same situation occurs in the kitchen back in our dormitory. While I'm listening to some music while I'm cooking, my hands are covered with water and oil. This time when I want to adjust my speaker, I will have to wipe my hands clean because I don't want to mess up with my speaker. These are the situations that I would like to have a touchless control speaker, so I can adjust the volume or skip songs just by doing gestures without physical contact between with my speakers. So our group designed a touch-based control speaker. Here shows working principle. The change of volume is realized by the ultrasonic sensor, which can detect the distance between your hands and the speaker. By moving your hands up or down, the volume will be changed accordingly. The second function of this speaker is switch source, which is realized by the PIR sensor. The PIR sensor can detect the movement of an object that radiates IR light. So by sweeping your hands in front of the PIR sensor, it will trigger the function of skipping switch source. Now I will give a live demonstration of our device. Sorry. Okay, when I put my hands here, the lights will off. It means it detects my hands. And when I move my and now it's turned down. Next is the songs. All right, just volume. Loving can hurt. It takes several seconds to let the PR cool down. So this display is like this. Here shows the detailed design of our system. Here is the ultrasonic sensor, which can detect the distance, and here is the air sensor that can detect your hand's movement. And the inside structure are shown here. As we introduced before, the ultrasonic sensor, the PI sensor, and the main chip, R3. And we add an extended MP3 module to control all the songs. It has an SD microcard to store all the MP3 files, and control the speaker. It's connected to the speaker. All right, that's all I want to share today. Thank you.
So my question is how you say at this moment most of people use infrared sensor, right? So do you think it's the best solution?
Infrared sensor to do
gesture, yeah.
Sensing. I think it's fine. It's fine, but sometimes it can trigger some mistake detection. Yeah. Because some people don't want to trigger anything, but just pass through the PI sensor, like the trigger function. Yeah.
So because there's another way to look at gesture, right? For example, ultrasonic sensing, ultrasound. So at least one star company from UC Davis, so that he uses this kind of managed ultrasound sensor array and then demonstrate he can do 3D sensing and much low power for this kind of facial recognition. You know, the one in iPhone 10 is infrared. using VC, like VCell, right? The 300 light source, right? A laser, like nothing, and then 3D, not infrared camera, but it's very, now, power consumption very high. So that's why people try to come with a low power, this kind of 3D sensing for this kind of gesture or facial recognition, right? So there's a different, from my point, there's no perfect solution. It depends on for sensitivity and also in terms of this kind of power consumption and things, right? So you, of course, some of this kind of infrared sensing for sure there's a way you can do it, but for some applications, a smartphone, maybe you need low power, so maybe there's some other method, right? Instead, yeah. So this company from UC Berkeley, East Davis, I think they're acquired by TDK. So all this sensor related smartphone is big business. That's why TDK acquire InnoSense and then acquire this start company from UC Davis, Silicon Valley. So there are many different competing technologies now. Okay, let's just tell you, it's always different things. Of course, this kind of motion sensing for human body has a lot more occasions. As I told you, for those VR, AR, virtual reality goggle or AR, there's a lot more. If you look at the HTC Vive Oculus Reader, my God, there's a lot of sensors. HTC Vive, there's more than 30 sensors for this kind of thing, for AR and the thing. So that's for gaming. People really want to very realistic gaming and then so they don't get money, they put a lot of money. I want to buy the best thing for playing the game. So this is the big business. Okay, anyway, so I just tell you, there's a lot more people trying to come up with all kinds of sensor, wearable sensor for this kind of VR, AR, and MR. Yeah. Okay. How about the next? Let me go to the next group.
once we get the reading, the resistance value of our sensor, we compare with the threshold value to judge whether we make the sound or not. And this is the debugging process in the initial stage, where we can measure the accuracy of the resistance measurement before we actually input our sensor. So now we will show you the final demonstration video. So as you can see, when we press it, it generates a sound. And we can play on the table. And also in any surface like wall or it's like paper actually, so any curvy surface as well. And this is actually changed for two. Yeah. So this is our final demonstration video. And for the future work as a room for improvement, we mentioned 3 different points. First of all, hardware. If we have more time to do so, we can add more sensors or provide user-friendly coding so that user can customize according to their needs. And also for the volume. I just saw the previous group was like changing the volume like this. So I think we can also add those kind of volume functions if we put another sensor to it. And also for
maybe better. Loudspeaker, with hi-fi and praise a good video, the sound, music.
And also lastly, sensor part. Sensor part, as we involve with common nanofiber sensor with the PDMS, there are a lot of experimental parameters that we can actually investigate. For example, the effect of different PDMS film thickness on resistance changes. If we investigate further on that, we might be able to optimize the resistance stability according to the PDMS film thickness. So these are the rooms for improvements. And this is the end of my presentation, and thank you.
Okay, any question or comment for this group?
I have a question. Have you tried to define difference ratio for the sensor?
Yes.
And what happened?
Sorry?
Difference ratio and what happened? If you
Difference ratio whole.
Yeah.
Yeah.
So our sensor basically is fabricated by carbon nanofiber, right? So every carbon nanofibers need to get threshold value different.
So you need to tune.
Yes.
You can see. Okay.
Yes.
I see.
Yeah. What you were asking?
Yeah.
Another question for you is why you use this particular one, carbon nanofibers sensor, not use commercial one.
We can actually. We can. That'll be
So
easier
what's the difference in terms of performance? Right? You say you can have your own special type sensor, but in terms of engineering, if you can buy commercial one, you can make product. If you do this thing, then it's very difficult for you to become a real product. So that's something for engineering. We need to find some low cost solution, high performance to certain kind of performance, right? So that in terms of this kind of sensing, I don't know, do you have an idea what's the requirement for you this kind of sensing? Yeah.
What's the
requirement? What for your particular one? You really try to see once your sensor really try to maybe sense your fingers motion, right? Okay. So that you need to think about what's the minimum requirement for this kind of sensing about human this kind of finger motion.
Okay, maybe I can explain. I can start explaining about why we use this.
Yeah.
So first of all, I mean, of course, as you mentioned, we could use the commercial one, which is a lot low cost. The reason why we use this is to show that we actually studied for the PDMS behavior, which we learned in class.
Okay.
So we wanted to try different things, which shows that we're actually working on our course material. And for the requirement part, Actually, I don't really quite understand what you mean by requirement part.
You see,
Can you repeat on
that's related to the cost issue. If this kind of sensing requirement is low, sensitivity or gauge factor, then you don't need, you have low cost solution. You see, if you only have a very small input output response, then you can use lowest low cost to make a good product. That's engineering thinking. Of course, for research, you try all kind of fancy material, nano, common nanotube, all kind of nanomaterial. But for engineering, if you want to make product, that's different thinking. What's the lowest price of sensor, and buy it away to make a real prototype and make product, make money. So that different kind of thinking, but this something is a good training for you. I do think. Any question or comment for this group? Yeah. Of course, another comment is if you can come with additional Bluetooth, so that I've been better, right? Yeah. Bluetooth, so that in this case you'll be and that is so cheap. You know how much is Bluetooth module for Arduino? About 15 RMB from Alibaba for sensor. So compared with your sensor, I think it's much cheaper. You spend a lot of time to say, huh? Do you agree? This is not really for me low cost. Yeah, I understand. I think low cost. Now we are for engineer. We are low cost, high performance. This kind of sensor system. So that is something you should think about. Right? We are engineer. Yeah. Okay. Any question or comment? Okay, it's not a private thing. This group. Okay. Yeah. $15, about $15.
Oh, is that the Bluetooth? Oh, okay.
And also have an app that give you the solution.
China.
That's why. If you want to make a product, then try to buy from Shenzhen through Alibaba, Taobao, and go this kind of app. Now, saying you can make a really product.
Is this for the sensor part or
sensor and sensor module, and also have the app connect to the smartphone and then say, yeah. $15 RMB.
To be competitive.
You need to leverage this kind of low cost for your product. Okay. Yeah, maybe I should share this one for the other student. Okay, you can start. Yeah.
We are group 7, and this is our handmade cutter machine. And look like quite simple, but not simple, because we not only about the mechanical design, but also software, electrical, and okay. For today, we will go through like background, working principle, and for our cutter. Yeah. like some research found, market expanded by 7.5% year on year in the first quarter last year. And then also, we can consider market like somewhere in the world, no bartender here, and also no technical things. But we only export one machine for that, and hotel is not difficult for them. Make their life easier. And then why we need this machine? It's like while we are staying in some bar or some club, and then like the background music is really insane, like like that one, yeah, like we did, yeah. So this is the one problem we met. Already ordered it, but I need to wait because in the peak hour, the club and some bars is really crowded. And then thirdly, like some formula can't satisfy us. Like I want last week, and I tell the bartender, I tell them I can't get the drinks I want because each bartender has different understanding on last week, right? That's it. So for our machine, solve every problem. Like for the user, because we can do it like online. We just make a website for that. And then this website can connect to the Arduino through the Python subscription. And then we have the tailor formula in the web. You can just adjust the portion you want for each ingredient. And then thirdly, accurate. For existing cocktail machine, they only use independent solenoid valve like the beer dispenser, like that one. But we add an extra pump, like a volume control pump. So that's accurate. And then finally, that is efficient serving. Like from order to get a drink is within 2 minutes. And then for owner, absolutely can cut the cost because can some increase the capacity for the drinks, and then also we can grow a database because all the order is from the internet. We have record. We can just build a database and do analysis on it. First one is quite good for the inventory management, and then second one is like while you spend money to do some marketing research, you don't need to because we have database. That's it. And then we can show you our website. Like here. Wow. You can just order one drink and then submit.
I see.
Submit by PHP. So this website protocol is HTML.
I see.
And in our computer there is a Python there.
I
So
see.
we can do a subscribe the PHP.
I see.
The database behind the PHP. Yeah, that's it. So how it works, like access our website when it comes through, and then click your drinks, and then Python subscription, and then the data is inside the computer, and then we just use the serial communication by UART, and then just transfer to the Arduino, and then after the Arduino receive the order, and then there is a light button will turn red, and then we press the button to confirm the order. Yeah, that's it. And then while it is mixing the cocktail, and then the blue light blinking, and then finally, if you finish the order, the light turns to green, and then that's all. And then after the green light turns to green, and then Arduino will send a finish to Python, and then to subscribe the next order. So demonstration time. Ready. Okay.
So can some of our students enjoy your? Sorry. Wow, my God.
Maybe
Wow. Wow, good. Wow.
After you choose what kind of drink you want to drink, water, and just press this button and you can start. So anyone pick the order, you can tell us and we will get ready.
It's free.
Of course it's free. Of course. Also we have pretend eyes. Yeah, okay, so who wants to try first? It's okay, we have drinking from it ourselves.
The first company say that.
What do you mean by not saying? What do you mean by that? Yeah. Yeah, because we also have a nobody has
Oh, okay. If you come out, we need to find who could give another order. Yeah. And then you will be.
yeah, we can use ours.
Yeah.
Wait a second, because we could refill the cup. Yeah, and then you can start making it.
Because for each of the drink, we have a total one for it. So,
Yeah, and we also have calibrate the volume of each kind of drink. So it will be the formula that you want.
So how did you try to adjust kind of ratio of different
Because every
liquid?
round is
Yeah.
a pound protein. The volume is controlled. So
Okay.
we use this to calculate the total volume of each kind of formula.
Okay.
Because this is the hydrostatic pump, and every time it rotates, the volume is controlled. Yeah.
we have tested some orange juice, orange juice, something inside. Yeah, and I just
And it's after it's Obama had a green hat.
Great.
Yeah, so anyone wants to take an order, you can just order. It's totally.
I think it's okay. Try.
You want to try another one?
It's totally free. Alright.
Okay.
There's the website.
I think you can QR code and just
We're also thinking of adding a screen, and you can just choose it from the screen.
So choose.
Or choose anything you want.
I expect the formula.
Submit.
Oh, wait a second. This one is really nice.
I press the button.
Yeah.
We also have the ultrasound sensor to detect if the water is overflow, to make sure that it will not be disturbed. So how many sensors? Sensing. Yeah, just
Oh, finish? Yeah, great. Let me try.
Are you okay?
Very good. I'm really enjoying the briefing.
Okay, any question for this project?
Okay.
Huh? Oh, yeah. I see it's great to have tried your real product. Friends older. That's buy your. Okay.
Application, you can see that it's a light indicator. Yeah. And ultrasound sensor for transit fluid, the water is going out, and then the one I don't know, but we almost used it for the
Mm.
5 relay for each. And then here is like kind of that. And then here is this one is a volume joint, and then this 5 is delay. And 4 is signal is coming out from and then this is the power supply.
Mm.
So we just plug it in. And like for the design, we can improve. Like here is some type connector, but not the tailor-made. So we use 3 connectors to connect into one type. So therefore we could have a problem is even the strings go to the top and then it will make it together. So we should to order a tailor-made connector, type connector. So 5 design. And then use software logic like we use Python to write the database behind the website, and then we take the order from it, and then after we done all the stuff, and then we send back in signal to Python so we can read the other. So for the future improvement, actually talk about hotel. There is a lot of games you can like shaking and then like stirring and some we need to like do some layer. So that's some object.
I see.
Yeah, motion for it. So that we will develop it in this way. And then actually for the serial communication, you can like change to Bluetooth or some Wi-Fi modules. We can do that like so no Wi-Fi connection.
Okay, any question, comment? I think it's quite impressive to see you can really reach this kind of level of this integration from mechanical design, electrical design, also the website and thing. Yeah. So that my question is how much is this total this kind of no? I see. I see. Mm. Okay, good. I see. Okay, so any quick comment? So I don't know. You are quite serious, so you really want to make a product for this kind of thing? What does? Maybe. Or you want maybe at least you make a good video and then try to get the crowdsourcing to see anyone to want to. Okay, good. It's quite very impressive to see you create this kind of prototype. Yeah. Of course, another question is so next step you want to make this kind of real fancy mixing. So what do you think? How you try to implement this kind of thing?
I think this guy can do it because it's already finished. It's some MPhil researchers from the other university, but we are doing that kind of thing. So I think it's a good thing.
Oh wow! Okay. I think probably you can have this kind of those kind of motor, right? Vibration motor, you know, in the vibration conveyor, something maybe use that. Yeah. I see. I see. But yeah, I see. But quite interesting. Yeah. Good. My question, another question is about for different professional this kind of way to do this mixing about the cocktail, so that I don't know. Do you think you can even better?
I think what is our positioning is like we add a volume pump because from European there is like auto machine they have an app like the operation is like us, but the main point is we do an accurate control for the
I see.
So that is our advantages.
I see. How about quality control? If you add additional sensor, camera or something, make sure that your quality of your cocktail even have some way to do the kind of quality control. You see, so that's an additional thing. Maybe you want to.
Yeah, why not?
Why not? Yeah, yeah. Just like I told you, the one I bought from that company in Shenzhen, right? So there's a low-cost camera. Do you know comparable this AIoT module that already have camera? Every whole module is less than 200 RMB. With AI, right? Everything with camera, with organic LED touch screen, screens, and this is not too expensive. Okay. Any other question? If not, probably thank this group. Okay, so go to the, I think almost the next one, right?
Hello, Dr. Lee, can you hear me? Professor Lee?
Gecko inspired glass screen system.
Sure.
Huh?
Sure.
What's that?
Group 8?
Group 8.
Here.
Oh, okay. So,
yeah, we want to do it via the Zoom conference. Can we do that?
Okay, can you give presentation now?
Yes, of course. I'm just trying to share the slides. Can you see the slides?
Oh. I think the sound is coming from here, not there.
Yeah, this is it. Can I hear?
Hello? Hello?
Yeah, we can hear you.
Okay.
Can you see the PPT?
Yeah, the slides.
Yeah. Please put in a full screen.
Full screen. Okay. Got
Full
it.
screen. Yeah.
All right. Should be working now.
Yeah.
Okay. Then can I get started?
Yes. Go ahead. Yeah.
Okay. Thank you. So here today, I'm glad to introduce a smart gecko gripper based on the Arduino board, and we are Group 8. So the presentation flow for today goes as follows. So first we will go with an overview of what we did, and we go through the basics on the gecko gripper, and then we should see how we implement the Arduino board to make this gripper really a smart gripper, and then at the end we'll do a conclusion and the future work. So so this is the overview of our designs. So on the right hand side there's the gripper. So basically it is a gripper for glass phone screens, and with the Arduino board and several sensors integrated into the gripper, we can achieve an environmental monitoring of the grasping environment, which is very essential for the gecko gripper technology. So in general, the sensors we use are listed as follows. We use a DHT11 temperature and humidity sensor, MQ2 gas sensor, a motion sensor, an RFID reader, and also a distance sensor. So before we get all started on how this system can really work, we go through the functionality of our designs. So first of all, we want to achieve a motion detection. So using the PIR motion sensor, it is only when an operator is presented near the device can the device be actuated and actually operate. So if no one is actually presented, if no one's presented, then the device stays unactuated and just everything stays normal. And the second part, because the working environment of the grasping is really important in this system. So we would really like to know that if there's any unwanted chemicals that are presented in the working environment, for example, the carbon monoxide and the liquefied petroleum gas. So if those gases are presented, then we would like to stop the operation of the grasping. Afterwards, we should also monitor the temperature and humidity of the working condition. Normally a factory, and those monitoring are actually very normal in nowadays factories. And then we would like to have an identity recognition using the RFID, because when unauthorized personnel is there, we don't want him to use the device. Otherwise, it is going to be chaos. So the last thing we want to do is want to build an phone app. So we can monitor all those information that's mentioned above. So through your mobile devices, we can really monitor the working environment and how the entire system works. I think I should explain what is a Gecko adhesion system. So what we are trying to implement this whole system into a gripper is a Gecko gripper, which we mimic the adhesion system of a Gecko. And that's also why it is very important to monitor all those environmental informations like humidity, temperature, and chemicals, because those environmental conditions are really important to the performance of our graspings. So geckos can grasp things because there are those tiny structures on the skin of their toes. In the graph, you can see there are multiple levels of those tiny structures, ranging from millimeter level to even nanometer levels. So we in the Gecko gripper, we replicate those microstructures just like what we did in MEMS, using the almost the same technology to replicate those structures and make synthetic adhesives out of it. So geckos are really known for their amazing ability to grasp to different surfaces. So with the correct monitoring of every grasping conditions, we can replicate that very good grasping motion and build a very powerful gripper based on such technologies. So here is an example of a very bad environmental conditions in the presence of hazardous chemicals. So normally, if everything is all right, the Gecko surface should be presented as the graph shown on the top. So the wedges, the micro wedges, the triangle shape should be very smooth and without any impurities on the surface. But in case if there is any hazardous chemicals presented, the surface will be contaminated. And if you really use an SEM to enlarge the surface, you may see that where I've highlighted the chemicals actually polluted the surface, and then the surface become destructed, and it's not smooth anymore. And that's also our research motivation, that we want that before we introduce this smart system, we can only manually operate without any feedbacks or data collection, and it is actually an unsupervised working condition. So using the Arduino system, we would really like to build a supervising system of the grasping operation and achieve a constant environmental condition sensing at a rather low price and simple systems. So one by one, I would explain how we achieve that using different sensors. So first, we use a DHT temperature sensor and temperature and humidity sensor. So that's capable of sensing the humidity and temperature changes via the voltage changes in the presence of humidity and the temperature change. So here is our code for the sensor, and sorry for that. And then we will use a gas MQ2 gas sensor to monitor the carbon monoxide and other hazardous chemicals that are presented to actually prevent the surface from being damaged. And these are the codes for our gas sensors, and the PIR motion sensor, as I mentioned, is for the detection of the humans presented and to actuate the entire gripper system. And here are the codes again. So this kind of repetitive. So here are the results for what we did with the PIR sensor and the temperature and humidity sensors. So as we highlighted in the red block, so it can actually monitor the smoke, the carbon monoxide, the LPG, and it also can it also can detect whether in human is presented. So next we use an RFID module actually to identify the if it is an authorized operator of the gripper. So here are the results. When the RFID token is granted, an access would be granted, and after if there isn't any tokens or the token is not correct, as demonstrated, we use a paper here, the access would be denied. So last, we'll have a mobile monitor that gathers all those informations in the same screen on one screen. So everything can be concluded here. So this is the smart gecko gripper on the middle. The other ones are other kind of grippers that are not smart. So actually, we believe that using this system, if we make it smarter, it can grasp heavier objects at a higher success rate. In other demos, we are only able to pull off very thin and very light objects like a phone screen or a PCB board. But actually with the smart sensing systems, we actually want to build a better gripper. So here is a demonstration video on the middle that's showing the gripper can pull up a smartphone, which is the weight is way higher than the other demonstrations. So that's basically what we did for this project.
Okay, so are there any question or comment for this project? Okay, I think it's good to see you make this whole system, right? So I want you to ask a fundamental question about the fundamental principle of gecko.
Yes, yes.
Can you simply describe how the gecko work, right?
Yeah, for sure. So unlike other systems that currently the mainstream grasping technology would include those suction cups and suction cups and mechanical grippers that actually use those squeezing forces to generate grasping motion. But in the gecko, it's quite different. So because geckos have those very tiny structures on the toe, those very, very small nano and micro structures, geckos actually uses van der Waals forces. So each gecko hair that's in nanoscale creates a very small amount of van der Waals forces to the surface it is contacting. And afterwards, if we have multiple, a lot of those tiny hairs, the small van der Waals forces actually adds up to a very, very big number. And geckos can support their entire body weight by only one toe, actually. So that's the mechanism behind all those gecko adhesion systems. If we go back, roll the slides back to here, these are the enlarged images of the gecko toe. So those nano structures are the key to gecko adhesions.
So I just share you about one paper in Nature, year 2000.
Yes.
A biomechanic of gecko single the hair, right? So that well, if you really have a very good understanding, good writing, you can publish paper in Nature.
And then I could probably graduate.
Understand fundamental principle and then good. Of course, I understand you are making the whole system, right? So that's, and The first is we have good understanding and the biomechanic of this gecko adhesion force analysis. How you try to do biomimetic this gecko system, I think, to make even better than gecko. While biomimetic, this kind of system will be imposing. Yeah. Okay. Other question or comment for this project? If no, probably okay. Within this group.
Thank you very much. Thank you.
Okay. Then do we have a last one? Group 9. Okay. Please try to unshare your screen, your gecko screen. And then you can look at the one I put on our campus website announcement. You can try to see about that thing. Right? So of course, I believe this kind of a sensor integration of the sensor with AI with even great future. There's no doubt at all. Right? At this moment, your smartphone really have this kind of camera with AI. Do you know what I'm saying? If you have a download the Google photo and then click this button and they can upload your picture to the Google cloud server, try to recognize what's this, what's that. You understand? And of course, you have a Siri and those kind of Google Assistant. They use man's microphone with AI to recognize the voice, and there's all these things related to this only two sensors, right? Single image camera, computer vision, and this kind of microphone with hearing. So in the future, all the humans' five senses I can see probably going to have some sensor and then link to AI, right? But of course, those kind of gas sensor will mimic the humans, this kind of artificial noise and also artificial tone. I think it's much more difficult, but I'm very sure in the future, gradually, people will develop this kind of sensor to mimic the humans, the five senses for the VR, AR, or MR in the future. That is very possible. And I will upload one more lecture about this VR, AR, and application about the sensor. If you look at the HTC, HTC Vive, this kind of thing, wow, it's very advanced. Also, Oculus, you know, Oculus VR, Amazon bought it for $2 billion. Can you believe? This kind of VR goggle, right? Then Oculus, right? The co-founder make very good thing for his video game and acquired by Amazon for $2 billion. So all this kind of VR, AR have another level of this kind of sensor application. Anyway, I will upload one more lecture for your reference. Okay. Yeah. Okay, I think that's it for today's this kind of presentation. Okay. Or maybe you want to enjoy additional content. Okay.